Hi, so let's start our first question for your AI 900. So a company employ a team of customer services agents to provide telephone and email support to customer. The company develops a web chat bot to provide automated answer to common question queries. So the question that you will have is which business benefit should the company expect as a result of creating the web chat bot solution? So do you have the answer for this first question? So the answer is it cannot be here because it doesn't increase sales, okay, because it's support. And it's not improved product reliability. This is important, okay? So for this question, it's quite easy because it's reduced workload for the customer services agent. So why? Because the chat here, the chat bot, okay, the chat bot, we do automation response to FAQ. So it's fewer repetitive questions for human agents. It doesn't directly improve product reliability, of course, and it doesn't guarantee sales, but it will save human effort. So let's have maybe a use case for that, for this question. So use case is Microsoft use chatbot in Azure support so that simple reset password or check subscription requests are automated. An agent only handle complex case. So that's why the right answer is B. Second question, we have this question about machine learning, ML. So for a machine learning progress, how should you split data for training and evaluation? The first answer is use feature for training and labels for evaluation. Second answer is randomly split the data into rows for training and rows for evaluation. The other one is use labels for training and feature for evaluation. And the last one is randomly split the data in columns for training and column for evaluation. So for that, let me first explain you some machine learning information. In machine learning, you have feature, okay, you have feature, and you have labels. So what is a feature? Feature is the input data, the information you give to the model to learn from. Example, let's say age of somebody, salary, city, number of children, education level. And what is the label? The label is the output we want the model to predict, okay? So example, whether a person will buy a product, yes or no. So features is the input, okay? And of course, label is the answer. Now, remember what is training and evaluation. Training is the model learned from historical data, future plus labels. It tries to find patterns, like people with higher salary are more likely to buy. Evaluation is, sorry, is testing the model on new data it hasn't seen before. We check if it predicts correctly and measure accuracy, precision, and recall. Let's imagine we want to predict if an employee will leave the company. The feature will be years at the company, the salary, number of training completed, performance score, commute time. The label is did the employee leave, yes or no? In the training phase, we give the model past employee data, futures, and label. In the evaluation phase, we test the model with some employee it never saw before to see if it's predict correctly who left. And the prediction used for a new employee we only give future, year at company, salary, and the model predicts the label leave or stay. So what is the good answer? Of course, it's B. The explanation is that training model learned from rows, future and label. Evaluation will separate the rows, same future label structure that the model has never seen. Unbiased testing. And column cannot be split because they represent future, not independent example. Use case, like I told you, if you have 10,000 customer purchasing rows, you train on 8,000 rows and test on 2,000 unseen rows. Okay. So let's see this more complicated question. It's question 3. So you are developing a model to predict event by using classification. You have a confusion matrix. We'll see what is it for the model. Score on test data as shown in the following exhibit. So read that, predicted, actual, the number here. You must use the drop-down menu to select the answer choices that complete each statement based on the information presented in the graphic. So they are 5, 11, 1033, 3951, correctly predicted positive. And they are exactly the same, false negative. So what is the right answer? So what we have here is that we have actual and predicted. So we have 1, 0 here, okay, and predicted we have 1, 0, okay. So we have true positive, okay. It's TP. The predicted is 1 and 11, okay. We have false positive, FP, predicted 1, okay, but actually 0 equal 5. We have false positive, predicted, okay, false positive, 0, but actual 1, 1033. And true negative, predicted 0, and actual 0, 13951. So the correct answer for the correctly predicted positive will be 11 here. Okay. And the false negative will be 1033. So let's say this model predicts whether a patient have a disease, 1 yes or 0 no. So we will have 11 true positive. So 11 patients correctly identified as having the disease. We have 5 false positive. So 5 patients wrongly flagged as sick, but they are healthy. We have 1033 false negative, meaning that 1033 patients actually sick, but the model missed them. It's very dangerous. Imagine. And 13,951 true negative, meaning that 13,951 patients correctly identified as healthy. So these models, for example, this show the model is very good at detecting healthy patients, but very bad at detecting sick patients because we have high false negative. So let me again explain you precision, recall, and accuracy, okay, in the confusion matrix. So what is it for? See, we have this confusion matrix. So in machine learning, it is used in machine learning classification problem to evaluate how well a model performs. Instead of just saying the model is 90% accurate, the confusion matrix tells us where the model is making mistake. Is it missing true case, false negative? Is it wrongly flagging case false positive? So it gives a detailed picture of error. Another example that we can have is imagine we build a model to detect if an email is spam 1 or spam or 0 not spam. So the true positive is the model correctly flag a spam email as spam. The true negative, the model correctly identify a normal email as not spam. False positive, the model wrongly mark a normal email as a spam, annoying because you miss an important email. False negative, the model fails to detect spam and leaves it in your inbox. Dangerous because you might click a phishing link. Where do you see this type of schema here? You see it, for example, in Microsoft Azure Machine Learning Studio. You can see it in TensorFlow. You can see it in Power BI with ML Visual. You can see in Databricks, in Google Vertex, in AWS SageMaker. Okay, so the right result, okay, you know that now the question, okay, is 11 here and 1,033. Is it clear? Let's continue.